All right, today we're going to be talking about parallel lines, mostly just the relationships that are created when you have parallel lines cut by transversal. And so there's lots of vocabulary in this section. And then later we will talk about how to solve for x and for missing values in parallel lines cut by transversal using the relationships that we learned about in this lesson. So let's go. First of all, if we have a set of parallel lines, here L and M are the lines that are parallel, and of course, being parallel means that they will never intersect, and then N is cutting through those two parallel lines, and N is what we call a transversal, and because L and M are parallel, then when N cuts through them, it creates two sets of angles, and there are special relationships about those angles where a lot of them are the same because N is going to create the same kind of angle when it hits L and M. So let's look at those relationships. Sorry. First of all, we also have the interior of L and M, so the space between L and M where angles 3, 4, 5, and 6 are formed, those are called interior angles because they're in between the two parallel lines. And then we have the exterior, which are angles 1, 2, 7, and 8, because they are outside the parallel lines. Now, corresponding angles, we will look at those, and corresponding angles are in the same position but on different parallel lines. And in this case, we have angles 1 and 5. Those are corresponding angles. They are both to the left of the transversal N and above the parallel line. And then we have angles 2 and 6. We also have angles 3 and 7 and angles 4 and 8. Those are all corresponding angles. And they're listed as pairs. So if we want to list our corresponding angle pairs, we would list them just as I called them out. Angles 1 and 5, angles 2 and 6, angles 3 and 7, angles 4 and 8. And sometimes you'll be asked to name a pair of corresponding angles. And as you can probably tell by looking at the different colors on those angles and the sizes of the wedges that mark out those angles, that corresponding angles are congruent. They have the same measure. Also, don't forget about other relationships that we've already learned, like angles 1 and 4, they would be vertical angles. We've already learned about that. And then angles 1 and 2, they make a linear pair, so they would be supplementary. Those are relationships that you'll have to continue as you add these relationships that are specific to parallel lines. All right, let's look at alternate interior angles. Alternate interior angles are interior angles, so they're in between the parallel lines. They're on opposite sides of the transversal and on opposite ends of the transversal. So here, if I look at angle 3 is inside the parallel lines. It is at the top and to the left of the transversal. So the angle on the opposite side, on the right and at the bottom, would be angle 6. So angles 3 and angle 6 are alternate interior angles. Again, if I look at angle 4 is on the right of the transversal and at the top of the transversal, and the angle opposite that, which would be on the left and at the bottom, would be angle 5. So our pairs of alternate interior angles are angle 3 and angle 6, and angle 4 and angle 5. And again, as you can see by the colored wedges that mark out these angles, that alternate interior angles are congruent. That means they have the same measure. If I know the measure of one, I know the measure of the other. And looking at those, we can also see that angle 3 and angle 4 form a linear pair, so angle 3 and angle 4 would be supplementary. All right, same side interior angles. Same side interior angles are interior angles that are on the same side of the transversal and opposite ends of the transversal. So here, if I start with angle 3, it is interior, it is to the left of the transversal and at the top. So I want an angle that is also on the left of the transversal but on the opposite end. So in this case, that would be angle 5. Angles 3 and angle 5 are same side interior angles. And likewise, angles 4 and angle 6 are same side interior angles. And so our same side interior angle pairs, 3 and 5, 4 and 6. Now, you can tell by the size of the wedges there, marking out those angles, but these angles are not congruent. Angle 3 and angle 5 are not congruent, but they are supplementary. Since angle 5 is congruent to angle 4, and we know that angles 3 and 4 make a linear pair, we also know that angle 3 and 5 are supplementary. Now, let's look at alternate exterior angles. Alternate exterior angles are exterior angles that are on opposite sides of the transversal and on opposite top of the transversal. So I need an angle that is to the right and at the bottom. And in this case, that would be angle 8. And if I look at the other exterior angle that I have there, angle 2 is to the right and at the top of the transversal. So I need an angle that is to the left and at the bottom of the transversal, so that would be angle 7. So when we look at our alternate exterior angle pairs, we have angle 1 and angle 8, angle 2 and angle 7. And alternate exterior angles are congruent. Now, let's look at same side exterior. I have angles that are going to be on the same side of the transversal. They're going to be exterior angles, and they're going to be on opposite ends of the transversal. So if I start with angle 1 again, it is to the top and to the left. So I want an angle that is to the left but at the bottom. And in this case, that would be, should be angle 7. I forgot to mark those the right way. And same side exterior angle pairs are angle 1 and angle 7, angle 2 and angle 8, and same side exterior angles are supplementary. Now, we'll have some practice with those so you can get familiar with this terminology. Have a great day.